Hello and welcome to an introduction to polynomials. Polynomials are a good example of how we can use math to cleverly describe some of the mysteries we're revealing about our world. We'll come back to that once we have a better grasp of polynomials. We first need to make sure we're comfortable with the idea of math terms, as that's what polynomials are made up of. In math, what do we mean when we say term? A term is a number and a variable multiplied together. In math, when numbers and variables are joined, multiplication is implied. The number part of the term is referred to as the coefficient. Co is a commonly used prefix that suggests things are connected or working together, like cooperate or co-author. The variable is some value that is undetermined and is raised to any positive whole number, including 0. Some commonly used variables are x, y, and z. But really any symbol will work as long as it doesn't represent a true value. Pi, for example, is a symbol but could not be used as a variable, as the value is known. In a polynomial expression, if there is more than one term, each term must be joined by addition or subtraction. Let's look at some examples of terms to help us understand them better. For the first one, the number part, or coefficient, is 3, and the variable part is the x squared. This is a pretty standard example. In the next example, the -5 is the coefficient, and the y cubed z squared are the variables. We can, of course, have more than one variable in a term. What about this term, xy? Is it a term? It doesn't seem to have a coefficient. Well, it does, it's just 1, and since 1 doesn't change the value of the term, we don't need to include it in the expression. We also don't need to include the 1s for the powers for our variables for the same reason. Finally, what about a term that is just a number? This coefficient seems to be missing its variable part. Recall from earlier lessons about variables that any variable raised to a power of 0 is 1. We can assume that if the variable is not shown, it was raised to a power of 0, and thus we do not need to include it here, as once again, it doesn't change the value of the term. Because we're left with just a number, we know the exact value of the term, so instead of being a coefficient, as there's nothing for it to connect to, we call this term a constant. Here's an example of a polynomial with several terms in it. Let's use our understanding of math terms to decide how many terms there are and identify the parts of each term. First, how many terms do we have? We look for the pluses and minuses and what they're separating and count. 1, 2, 3, 4, and 5. We have 5 terms in this expression. Next, let's identify the parts of each term, starting with the coefficients. Remember that coefficients are the numbers multiplied by some variables. We see a 5 in the first term, a 3, a -2, and then we have the invisible 1 with the z squared. Next, what are the variables involved in our expression? We see an x, a y, and a z. So our variables are x, y, and z. Lastly, do we have a constant in this expression? We notice that the last term, the -10, is all by itself. This implies a variable to a 0 power, and thus we know that the -10 is a constant, as the value will not change. So, in our brief introduction to polynomials, we worked on making sure we're comfortable with identifying terms in a math expression. In a term, we identified coefficients, the number part that is joined to the variable part. We recognize a variable part, which has an undetermined value shown by a symbol raised to a whole number power. Each term must be separated by a plus or minus sign. And that if there is no visible variable, it's assumed the variable is raised to the 0 power, giving us a term with a known value that we can now describe as a constant. We are now ready to explore polynomials in more detail in our next section.